What's up, guys? My name is David. I'm Evil Otaku on the Discords, and I'm here to try my hand at some shorter form content this time around. The next few videos here, we're going to be diving into Netcode for entities, and we're going to be going through the basics here at first. It's not going to be very flashy, but it is going to get the fundamentals of some of how ECS works and dots in general. And how Netcode works specifically. So we'll get this going here. Hopefully it won't be as long as our other videos. But today we're just going to talk about just connecting, right? So the very first thing that you'll do after you install Netcode for entities, I guess we'll go over the real basics. So the way Netcode works for entities is that it will separate your client and your server into what's called worlds. We will see that here. You'll see in the entities hierarchy that right now we don't have any world here. We should have, because I gotta hit play. We should have an editor world. I don't know why that's not there. There we go. So just hitting play on an empty scene, we have this default world that gets built. And you see down here your systems. All of your systems start running down here automatically if they have the entities for them. Here you have this drop-down menu. It'll give you all of the worlds that are currently created. And so what is actually creating this default world is what is called the bootstrapper. And the bootstrapper is here. Hopefully you guys can see that. We'll make it a little bit bigger. So this is a class that comes with Netcode for entities. It's called the ClientServerBootstrap. And you override it to create your own. Basically, all it's doing is running this initialize script or function, and then it will use an auto connect port. There's some other function properties that we can set in order to connect. So right now, it is set to 0. When the auto connect port is set to 0, this is set to manually connect. We'll go over how to do that in just a second. But if we are not manually connecting, so say we set this port to something we want to listen to, I think by default it uses 7979. You can use whatever you want, as long as it's not already taken. Then we will roll through the initialize. And what this does is this will create a client world, and it will create a server world. And then it will automatically connect the two. By default, if you have the port to 0, nothing will actually happen when you initialize, and you'll need to create the local world, which is that default world that we saw before. We can actually show you a little bit here. Hopefully this works. So yeah, this is the actual class. I guess one thing I forgot is because the ClientServerBootstrap is not actually in the scene at all, you'll need to have this Unity Engine scripting preserve here on the top of your class there. And this prevents it from getting stripped out whenever you build your game. If it's not referenced in the scene, it gets stripped out of the build and it won't actually run. This is important here, this maximum thin clients. We'll go over thin clients in a separate video, but there is a tool window here that will let you create thin clients. So if you want to test your game, with just fake connections. This window here, this multiplayer played mode tools, will let you just spin up by default 32 thin clients. But we'll go over that more later. I guess the important part here is this play mode type. You can set between a client server, which is like your host, just the client, or just the server. And this gives you different options. With your client, it'll give you a address that you can set, or the port, or the server. It basically pretends to be either a client hosted server or a dedicated server. You would use this if you have a built-out client that you're trying to connect to. But we'll leave it here. With the client server here, you have different network simulators. So if you want to simulate real-world connections instead of just testing on your computer with zero lag, you would want to change this to be more realistic. All right. Back to the Bootstrap. So down here is just the create local world. This is that default world we saw earlier. It is just a new world, and the worlds are basically where your entities and systems will actually run. By default, the default world is kind of be used for like a single player game, right? You would just have the one world. Things like physics and stuff can have its own world as well. And this is the initialize here, right? So when you just run your base initialize, it'll create these default client server worlds. We just run create world, you give it a name. Same thing for the client as well. And also the thin clients. When we set more thin clients, it'll create a thin client world. Okay, that's basically what you need to know there. So there are other ways to actually connect as well, besides using the auto connect, which is good for just testing kind of locally, or if you're using just a regular client host system. But most often you'll want to connect afterwards, right? Like you'll be at your main menu, and then you'll want to start the game, then connect. For that, there's a couple of ways. We have here a connection manager that I made earlier. And these are basically the two ways of connecting. So the first thing that you would want to do is you just call your client server bootstrap. It's a static. Create server world, create client world, just like in the actual bootstrapper. Now, the bootstrapper itself created a local world already. We don't really want that world kind of hanging around, because that will basically just take up resources. Technically, it's an empty world, so it's not that big of a deal. But just to keep things simple, what we'll do is after we create the server and client worlds, we will just destroy the local world. And what this does here just loops through world, the entities.world class.all. This is all of your worlds, loops through them. When you create a world, they have world flags, and there's a number of these. But for the default world, the flag is game. We loop through them all, find the game world, delete it. Then at that point, we want to set our default game object injection world to be our server world. Because we are a host, client and server, we'll just take the server world as the real world. This little operator here is what's called a null coalescing operator. I really like this because it just will set this property here to this server if and only if default object world is null, which it would be since we just destroyed it. At this point, this is where you would actually change scenes. So you would load up your actual game scene. But after you change scenes, then you want to actually connect your server world and your client world. Because right now, they're just separate. They're two worlds running in parallel. The two ways to do this is with the network stream driver. Here, we'll just first, if you're familiar with how dots and ECS works, you just create an entity query, and then we will get our singleton, because there is only going to be one network stream driver in this world. And this is in the server world entity manager. We'll grab our stream driver. We get the singleton read write because we're going to be adding to it. And then we call the listen function. And the listen function just takes a regular endpoint. And we are using the default listen address. By default, that's 0.0.0.0. And then we'll give it this port. And this port, I just have a public string, or you short for it. The third way to actually connect is to use the network stream request listen. And it's basically the same thing, but we are just setting a component data of network stream request listen, and we're just dropping that in our world. There is a network stream request system that will pick up on this and then start listening. You would use this method here if you have a custom network stream driver, which we'll probably go over that soon, if not the next video. We'll connect to the relay service, and that will need its own custom network stream. Right now, this is just connecting directly to an IP address. And the same thing with the client. So we take our client world, get our stream driver singleton, and this time we call connect. And connect takes an entity manager and an endpoint. Basically the same thing, but the default connect address for the bootstrapper, this is the loopback address, 127.0.0.1, and our port. You can change these default connect and default listen addresses. You can change that in the actual bootstrapper if you choose, but generally the default is going to be fine if you're connecting on the same machine. And yeah, we can actually see this in action. Here we can create a empty network manager, drop our connection manager here, call our port and here we go. So we see our client world, we see our server world. Same here in the entities hierarchy. we have our server world, our client world. You can tell that it is connected through the play mode tools. It will tell you here that your server world is connected, your client world is connected. We could spin up a thin server if we want to. That will make a thin world. Let me just delete it. Down here, we have a network connection here. And then in the inspector, this is our network ID. So that's basically how you connect. Next video will get up soon. We'll talk about actually communicating between the client world and the server world through RPCs. So look forward to it. All right, guys, if you got any questions, definitely leave them in the comments. Hit us up on the Discords. And yeah, have a good one.